A thin-walled spherical shell is subjected to an internal pressure. If radius of the shell is increased by 1% and the thickness is reduced by 1% with the internal pressure remaining the same, the percentage change in the circumferential stress is. Options are option A 0, option B 1, option C 1.08, option D 2.02. Now the answer is, in a spherical shell, if the diameter of the cylinder is more than 20 times the thickness of the shell, it is considered to be a thin spherical shell. Since it is a thin spherical shell, both hoop and circumferential stresses at any location and in any tangential orientation must be same. But in a thin spherical shell, we know hoop stress sigma h is equal to Pd by 4T, which is equal to P into 2R by 4T, that equal to PR by 2T. Now let us apply logarithm on both sides. That is, log sigma h is equal to log of PR by 2T, that is equal to log P by 2 plus log R minus log T. Now differentiate on both sides. D sigma h by sigma h is equal to, since pressure is constant, derivative of log P by 2 is 0. So 0 plus dr by r minus dt by t. In the problem, it is given the radius of the shell is increased by 1% and the thickness is reduced by 1%. So dr by r is equal to 1%, which is equal to 0.01, and dt by t is equal to minus 1%, which is equal to minus 0.01. Now substitute these values in the above equation. D sigma h by sigma h is equal to 0 plus 0.01 minus minus of 0.01, which is equal to 0.01 plus 0.01 equal to 0.02. Now percentage change in hoop stress is equal to d sigma h by sigma h into 100, which is equal to 0.02 into 100, that is equal to 2%. So the correct option is option D, 2.02%.